It was developed with numerous interviews with experts from the mining industry, with OEM, with universities, and we came to a number of challenges and a number of trends where the mining industry is going to develop to. And one key message was that digitalization is the major key to drive productivity, to drive efficiency and safety in the mining industry for the future. And this is addressing all major challenges that are out for the mining industry. It's the lower ore grade, which you are encountering now every day. The high grade deposits are being depleted and the ore grade is going down. At the same time, the mines are getting deeper and deeper, and eventually they have to go underground, which is an enormous hit on the cost side and which brings enormous in regards to safety and continuation of the operation. And safety, health, and environmental protection is another strong lead. This means your CapEx, your OpEx have to be really carefully, and this is these are the main drivers to bring down the productivity and to increase your costs. So also the development of new mines from design to operation needs to be accelerated. And availability is a key for the operation to make sure that the mine is running. And for this all, we have developed an architecture which is the basis for our digital mine model. And please excuse me for this sort of busy slide, but I'm going to explain a little bit what we mean with that. So first of all, digital mine for us is in particular the horizontal life cycle of a mine. It starts with the mine planning, with the mine design, the process design. It's going through the construction and assembly phase into the commissioning and eventually into operation. The key here is that we can, with our solutions, ensure an integrated engineering, which goes over the entire life cycle of the mine and which makes sure that it is also in the database. And this is one important pillar for our digital mine approach. A common database which is going through the entire life cycle. With this database, we also can link to the process automation, and we can do a pre-programming, saving costs on the engineering of the process automation. This helps the entire startup phase and the entire engineering phase of the mine. And once we have done this, we can run the simulation of the entire process flow to make sure that the process is working as designed and that the automation system is doing what it's supposed to do. With that, it's possible to do a virtual commissioning and pre-commissioning, and at the same time to train the people who are later on running the mine. All the operators can be trained with this simulation. When it comes to the operation of the mine, we have all the data systems and we can run further algorithms in order to come from a condition monitoring to a predictive maintenance and even further. So it is all over the life cycle, working with one database. We are building up a virtual 3D model of the mine, which again is then the right means, for example, to train service people. They can do any repair upfront in a virtual reality, and later on they can do it in real. You can do emergency trainings, whatever. Our virtual reality environment allows for that. And all the maintenance and repair, modernization, renewal documentation, again, will be in one central database. So the documentation is always up to date. That's what we call the horizontal integration. Then we talk about the vertical integration. Oops. And the vertical integration is going from the field level through the process automation and the strong digitalization layer into the corporate ERP system. So it's a direct link into the planning, resource planning, and also into the executive dashboarding, management information systems. This is all going through the vertical integration with a strong MES, we call it MOM, Minerals Operation Management System, which is building the link from the field to the ERP system to the resource planning. And as a third layer, which is also part of the whole cycle, we can do that on a corporate level, and we can run closed loop also with all processes, with the asset health conditions, in order to really have a closed loop, go back into the engineering and make sure that availability and output are on the optimum level. And with an end-to-end logistic optimization, we can not only support the mine from the planning to the operation, but we can also support from pit to port the entire value chain of the mining company, including all the logistics. And how we have implemented that and how we are at the moment implementing that is what Eduard is going to introduce to you, because don't forget, the future starts now, and in the best case, it has already started. Thank you very much.
Thank you very much, Roland, and hello from my side. So what our clients facing today is slightly different situation as we had a couple of years ago due to pandemic situation. We all hit hard by this new situation where we face to work from remote, where our access to sites is limited, where we need to get used to another kind of work, where the consumption is different, and sometimes it's higher, lower for the different. Some of the regions in the world we face economic crisis. In some cases, digitalization is seen as a help, sometimes as a threat. We also see the generation shift in the mindset of the people, that where it's maybe difficult to find the right and proper people with the digitalization skills to go to site in the rather remote control activities for the site from cities, from offices. So our clients asking us how can Siemens help to create more productivity, to lower their downtime, to increase the maintenance intervals, to optimize their predictability, and to find strategies to decarbonize. Our customers also tell us that mining industry has thus far been limited by legacy infrastructure, data inequities, and piece metal optimization programs, and therefore big mining companies looking for an holistic approach. Well, this approach we always hear is we're asking us to digitalize for digitalization technologies. We have a lot of digitalization technologies, clouds, digital twin, big things, big data, and Internet of Things. analytics and artificial intelligence. But all of them has one thing together. It's about data. So data is the key factor, and a lot of data is needed to make the right decisions in order to achieve the goals that we're speaking about. So there is need to integrate and provide the data in the right manner, but especially also in the right quality to make the decision based on data instead of experience, which is sometimes available and sometimes not. So therefore, as Roland just explained, we think we need a vertical integration through different levels of organization and also through different people and tools. We have the maintenance operator, we have the engineer, we have the plant manager, the operation manager. They all rely on data, but the data needs to be aggregated throughout these different levels. So, but the result is the same. So we have the same data, but with a different view on it. So if we could provide the same data with a different view, which is always available and always up to date, this would be a big risk reduction. But we need to overcome some challenges like data silos, legacy projects. Data is outdated, tools are outdated, knowledge lost due to people retired or leave the company. So if we could overcome this would deliver stability, and stability reduce the total cost of ownership and delivers EBITDA. So in the best case, it would be an out-of-the-box holistic integrated solution for software, where you create the data only once and transform it through the different phases of the project that is always up to date and accessible for everybody and the view that he needs. Okay, now let's see the Siemens answer and the portfolio that we think can solve a lot of issues and give answer to this kind of question. Next, please. So what we see here is a vertical stack of software packages and a solution that we called a digital twin of facilities or digital mine. This is an excerpt about our portfolio elements with the focus of engineering grow together with the operation, and the engineering data grow together with the operation data. Within this holistic integrated software stack and solution, data is always up to date, and in each phase information flow seamless through the vertical stack of software, organization, and people. And this solution answers a lot of questions to this. Answer a lot of questions actually. Yes. So let's have a look on the different packages. We do have on the level 2. So what you see here is a digital mine according to the ISA 88 with different levels and our software packages that we provide to Siemens. We see on the level 2 the DCS solution PCS7, which deliver the solution for process automation, but also for medium voltage SCADA system. The underlying technology that we use here for as a PLM, as a project lifecycle management tool, is COMOS. COMOS delivers a database where different disciplines are included, but always on the same data. COMOS contains process and automation part, where we keep the data between the DCS and the COMOS tool always up to date, where we link this data between the different tools like ENICs, PNIDs, the document management system, COMOS PQM, but also the maintenance and operation tool, MRO, all together. We deliver different views on the same data. We do have also simulation tools that deliver us a realistic process simulation that helps us during different phases of the project to test our DCS against our simulation, to evaluate changes, to do virtual commissioning, to train our people on the original software, on the DCS software, with the data coming from COMOS and DCS on a realistic environment, but on the same data that we created during engineering. And it also is available during the lifetime of the project or plant. It can be used inside of the remote operation center to train the people and to elevate new maintenance strategies and to elevate changes, to do changes in their impacts before going to site and implement them on site. COMOS also deliver a 3D model that link the 2D data with this 3D data. So we are able to reuse the data that was created during the engineering for the 3D models and deliver a tool, walk inside, where the users, the operators can be trained in a virtual environment, see the realistic environments inside of a 3D tool, and can be trained in maintenance strategies, but also can evaluate training scenarios and see directly, link directly data from 3D to 2D and DCS system, PNID and ENIC. All our tools here that you see are fit for virtualization. So we use the virtualization usually for our tools, which is easier to maintain, scalable, more flexible, and all of our products are capable to work on virtualization systems. We do deliver also an MES system called Semantic IT, or some know it also as short interval control, where the management of the schedule system is to be done. So if anybody go to work, need to know what he needs to be done and where to find the right equipment, this tool will deliver all the data that is necessary. The work will be coordinated right across the operations inside of Semantic IT, our MES tool. So the goal is to bring the plants or shifts plants and the knowledge that is needed, the data, the position of the equipment together all at one place, to bring this data to the people that needs to do a plan, like shift coordinators, supervisors, bosses, and all these kind of people that executing and leading teams who need to know where they're up to in comparison to the plan that they are, if they are off the plan, how to get back to the plan. We do have our XHQ system. XHQ is a tool for operation intelligence on the market since 20 years, and it's aimed to provide better operational decisions and actionable decisions by integrated data from different data silos in different places, contextualize, aggregate data, and serve the user exactly the way they need to make a decision they need to do. The main idea of XHQ is to institutionalize the best practice and dashboards so that the screens represent the infos you need, like the data you need on each level, from engineering up to the plant manager as described. So the XHQ delivers the possibility to monitor from Office Network for data like to look on the numbers of beds available, production codes, health, safety, environment, positions of equipment like driller, trucks, and so on. Next, please. All out. Let's have a look on some of the key elements of our software portfolio. Due to the time, we can't go through everything, but I will focus on 2-3 main advantages of this tools. Let's have a look on COMOS. COMOS is our PLM software project lifecycle management tool, and with its unique data platform, it integrates and provides plant data designed for engineers, plant operation personnel, company management, and solution partners with a continuous flow of data that meets their specific needs across the project phase. One requirement for effective plant management is optimum network and coordination of all disciplines and departments involved in the engineering and operation of the plant. So the software solution COMOS is basic for the cooperation of a worldwide collaboration across the entire life cycle of the plant. The integrated COMOS software concept is based on object orientation. Components are described holistically and displayed graphically in their true-to-life representation. The graphical and data-related description, which includes all data associated with the component, forms a single unit within the database, so the object, the data itself. So related data sheets, lists, and other documents are linked to the corresponding objects. So you have everything at one place, always available, on field, through tablets or devices in the office, and can be connected remotely from everywhere. So the complete plant information is the result. COMOS allows all disciplines involved in the engineering and operation phases always to access the same data. Objects can be drawing. The change and what they are up to date, and then they are up to date, and individual components can be examined and further developed. So let's have a look on one or two key aspects of this integration. Next, please. What we see here is a part of what we've shown you before. We call it the integrated engineering. So integrated engineering, this integrated engineering approach allows us to use the created data during the detail engineering, during the that is available already in COMOS or migrated from third-party data, to make use of them to create our DCS and PC7 system. The routines inside of the DCS system. It has an interface in both directions to the DCS system, but also the simulation system. So it allows us to use the data that comes from engineering directly linked to the DCS, but also in the simulation for engineering, e.g. for testing the DCS routines against a simulation, which can be low fidelity or high fidelity, but also bring this data back, so it's bidirectional interface, bring this data back once changed and filled to our COMOS plant lifecycle management tools and document it right after the change. In this way, we establish the data to be always up to date and stored in one database, accessible for everybody on the world worldwide at the same time. And it gives us also an opportunity, next please, to do what we call such a virtual commissioning. A virtual commissioning is a phase we performed in the office network before the engineering and the pre-commissioning starts. So it allows us, or the purpose is to test and validate, integrate the vertical software stack after the engineering, before the commissioning, to find and introduce interface issues, the overall integration into the system done and smooth integrated long before we're going to site. Usually the sites are at remote places with higher cost to access. There is more pressure on sites, and due to the pandemic, very often there is limited access. So it would be very beneficial to test and validate the plant, the software components working on site long before we go to site. And it allows us to involve operations, maintenance, plant managers, and react and incorporate and react to their needs before we deploy this to site. So usually we also face a gap between engineering and commissioning or site operation. And with this approach, we close this gap. But we can also use this approach if, for instance, we face changes to be done on sites. We can do the changes in our office network environment long before we go to site, evaluate, test them, and just go with a solution on site. And we can also, with this approach, keep our data, as shown before, up to date in all of our databases, which is then accessible from everywhere, every time on the world. So in this way, we think we can reduce the total cost of ownership by keeping data accessible, available, and presenting it in the right form to the people that need it on site, but also in their offices. Thank you. This is it so far from my side.
So thank you very much. You can imagine we could have introduced much more in more detail. Unfortunately, the time is limited. If you have any questions, please do not hesitate to call, ask now, or to contact us at a later time.
Yeah, we have your contact details, but we have also some questions from our audience for Eduard specifically. So if you don't mind, I would like to read them for you. What is your assessment, Eduard, of the use of this integrated engineering approach in terms of return on investment, increased productivity, for instance?
Yes, so the main benefits of this integrated engineering approach is to use the data only once. So if in this way we can establish a data flow and also reduce the risk and of course the cost that in, let's say, misengineering will cost us because the data is not up to date. So we really think that on one hand side it will make our solution cheaper because the data is up to date, the data is reused and only in one place during the engineering phase, but also during the life cycle of the plant, which is, from my point of view, the bigger portion of the cost, because the total cost of ownership of the during the lifetime of the cost are higher, let's say, during operation and not in engineering.
Okay, thank you, Eduard. We have another question for you. This is the question. In a digitalization solution, what is the cost impact of ensuring a secure environment based on the latest cybersecurity standards, Eduard?
Very difficult to answer. Roland, maybe you can help me here.
Yeah, so it's difficult to come with a cost evaluation on that. The key is that cybersecurity is our key topic when we talk about digitalization solutions. It's built into some of the components, but of course we also make sure that by putting together our software components like COMOS, CIMIT, or also our PCS7, that we go beyond and make sure that also in the integration everything is secure. I mean, sure. This is the key, because we cannot run the risk of having a cyber attack on a mine which we have equipped with a digital solution. So this is the highest priority for us, to ensure the security and data integrity.
Sure. It seems like a critical issue for the whole industry. Absolutely. And the whole process. Well, thank you, Roland, Eduard, for sharing your thoughts on this with us, with our audience. As I said, the contact details are in your presentation, so they will be available for all our audience. Roland, Eduard, thank you very much for being with us today.
Thank you very much for having us.
It was a pleasure.
And enjoy the rest of the day. Thank you.
Thank you, you too. Gracias.
De nada. Nos vemos.
Bien, agradecemos por supuesto a Roland también.
We would like to thank Roland and also Edward for this presentation about the Digital Mine project. It's explaining its characteristics and benefits for the industry. Remember that all these presentations are in our website, mineralweek.cl. And as Roland and Edward said, the details of contact information are in the presentation, in the final slide, and you can write them as Roland and Edward invited you to do, to go deeper into more details and clear some questions that you may have. And to finish the day today, we will continue with our Siemens Mineral Week presentation 2021. And before we continue to the final presentation, I would like to remind you that through the website, you can send your questions with the hashtag Mineral Week, and you can send your questions for the final presentation or for tomorrow over social media and share your ideas and comments about the topics that we've talked about during this morning and the ones that are yet to come. Remember that tomorrow we will have the final session of the third day of this Mineral Week 2021 from 9 a.m. till 1 p.m. with this talks of our panelists, and we will have a panel to open this 2021 version. We'll have a panel to go deeper into more development of digitalization and automation in the mining industry. We will have that panel with the presentations so you can connect from tomorrow starting at 10 a.m. and over the different platforms of CNN Chile and over our website and social media and .cl. We will have the presentations too. We will continue now with a success case of the implementation of this solution, digital solutions for the mining industry, specifically to analyze the case of an important mining company, the huge giant Vale, and to go deeper into how we implement the digital transformation in the supply chain of this Brazilian giant. It's what we will talk about over the next minutes with our final presentation of today on Wednesday to continue with the second part of Siemens Mineral Week. Remember that in the website we have the channel open so you can leave your comments and questions for today about the topics that you've already seen, and of course the next presentation that our next guest is bringing. Nehemias Bastos is the one that will be with us today, and let me tell you a little bit about Nehemias. He's a project manager of TI and Vale in Brazil, and he will talk about the transformation of the supply chain of Vale, which is a success case of those that we are going over in this Siemens Mineral Week 2021 session, about the implementation of these new technologies, the automation and digitalization process that moves the mining industry forward. And in the case of Vale, as we said, it's a reference at a global level because of the size and the work that the Brazilian mining. And we will have Nehemias Bastos in a few minutes so he can tell us more about the case of what they have had as experience in Brazil and the conclusions that we can get out of this topic. We will take a short break, a couple of minutes, and we will be right back with Nehemias Bastos to close this second day of Siemens Mineral Week.